So you are ready for that?
Of computer science?
Yeah.
Yes, sir.
Okay. Now, do you remember what we have done last time?
So last time we have done the on and off.
No. Did we discuss fetch, decode, execute, clock speed, number of
Yes.
processor?
No, sir.
We have, I think
I
we
do
have done
not remember that.
number of processor. Okay. Try to take screenshot when we end the class, okay, so that you can memorize where we were.
Okay. Sir, can you send all of the recordings that we do the work?
Yeah, I will send you question answer, okay, of this chapter.
Okay.
Okay, so basically now we can see from here number of processor core, okay, number of processor core.
Processing.
So basically tell manufacturer introduce multi-core processor. So you can have a multi-processor in your system in 2006 to increase processing speed. Okay, so it says a multi-core processor has more than one processor core, but only one CPU. But only one CPU.
One CPU.
So it means one CPU can have more number of cores. You can say small CPU. The following diagram illustrates the structure of dual core processor. So it means you will have a core 0 and core 1. Basically, these are two core, means two processor, which will have on control unit and on ALU. Core 1 also will have a control unit, and core 1 also will have a ALU. Okay. The purpose of introducing core to increase the efficiency, to improve the efficiency of system. Got the idea? Now here you can see number of core means single core. Okay, if you two core, we call
Okay.
dual core. When do you have 4 cores? So quad core. 5 core means pentacore. 8 means octa core, and 10 means decacore. Okay, so these are terms given. Okay, according to number of core. Okay, let's say the advantage of multi-core processor over a single core are that the one core can be together on the same program. This is called parallel processing. Parallel processing means two processors working on one task. Okay, and they divide the task on different program at the same time. This is called multitasking. Okay, different program at the same time.
Okay.
This is called multitasking. So parallel processing means one task divided into multiple processor. Okay, so multiple processor working together on one task. This is called parallel processing. However, not all programs will run at twice the speed with a dual core processor. The task required might not be able to be carried out in parallel. So they might be sequential, so that one task require output from a previous task. So this means the second task cannot start until the first has finished. Okay, this is the demerit. This is the demerit. So it creates some problem to perform quickly. So this is the demerit of using a dual core processor or multi-core processor. Here you can see a definition of multi-core processor: a processor with a many processor core. Dual core processor means a processor with a two processor core, and single core
Hello.
1 second.
Sir.
Yes, sir. But what happened?
Sir, actually, there's issue with the net. That's why.
Okay. So basically, we were discussing these definitions. Okay, you should go through this one. These the
Okay.
these definition. Okay, move to next part. I think I remember size of cache. Do you remember size of cache?
No, sir.
Do you know where cache exists in computer?
No, sir.
I told you last time. You forget. Now this is CPU.
Yes, sir.
Okay, CPU connected with the
Okay.
cache. CPU connected with the cache. We also call
Yes.
cache memory is a SRAM. This is also called SRAM. Okay,
Yes, sir.
cache connected with RAM. Okay, cache connected with RAM, like that.
Yeah.
CPU also connected with RAM. This is the way connectivity. The main thing, cache size.
Okay.
Cache size very matter. Also RAM size also matter for the efficiency of computer. Now it says bottleneck occur when one component cannot work as fast as the other component and so slows down progress. And the fetch execute cycle, this bottleneck is caused by the main memory that is used to store the instruction and data. Now it is talking about RAM. Okay, it is talking about RAM. I told you before that RAM hold data, instruction, and program. One program is OS, operating system. Rest program opened by user, like these. If you are opening browser, you will open new tab, new tab, new tab. Okay. What happened? Your RAM become full. Your RAM become full. So processor unable to store data or unable to get instruction from RAM due to become busy by the RAM. Okay. So that is why cache memory was introduced. Okay. So that CPU can transfer its result to the cache or it can pick instruction from RAM or cache. Got the idea?
Yes, sir.
So it says instruction and data, although far quicker. It says instruction and data, although it is far quicker to fetch the instruction from the main memory than from a hard disk driver. So hard disk is much far away from the CPU. The RAM is still far slower than CPU. So CPU is more faster than RAM. So the instruction then have to be transferred to the data bus. Okay, all instruction or data
Okay.
transferred through buses. Do you know buses? There are three types.
Yes, sir.
There are three types of buses: address bus, okay, data bus,
Okay.
and control bus.
Okay.
Now it says the instruction then have to be transferred through data bus. Okay, the speed of processing will be limited by the RAM, so which supplies the instruction regardless of how much clock speed is increased or how many cores are used. Solution to this bottleneck problem is to use faster memory very close to or even. So this memory used to store recently used data. This is very important, and data likely to be frequently used, which is called cache. So most CPU have independent instruction and data cache. The data cache have to be read and written to, but the instruction cache just have to be read by the CPU. The use of cache allows the CPU to check fast the cache for the data it needs. It does not have to wait for it to be fetched from the slower main memory. The faster SRAM is used for the cache. So basically, CPU basically the first step getting instruction is called fetch. Second is decode. Okay, and third is execute. So every time
Okay.
perform these steps whenever it get instruction from the main memory. The main memory, I mean RAM is slower, so that is why the computer engineer have introduced cache. As I told you, cache exists between. Remember, cache exists between CPU and RAM. Okay, processor and RAM. Okay.
Okay.
Now cache comes in three levels. The cache are located on the processor chip. The fastest is the level 1 cache and is smaller than the level 2 and level 3 cache. The level 1 cache is checked first, followed by the level 2 and then level 3 cache. So CPU checks first level 1, then level 2 and then level 3. Okay, got this point?
Okay. Yes.
Now the cache are located on the processor chip. Okay, this one we discussed. Here you can see. Okay, these are cache. Level 1 cache, level 1 cache, level 2 cache. Level 1 D cache, level 1 D cache, and level 1 D cache. Each core has own cache, okay? Each core has own
Okay.
cache. The level 3 is outside the core. Level 3 is outside the core. Okay, now go through this one. Secondary storage. Then I tell you, okay. The second storage is secondary storage. The first storage was primary storage. Just go through quickly. Then I tell you.
There from where?
In most situation, from here. From here. Just go through.
Okay. Sir?
Yes. Have you gone
Sir,
through?
can you send me all of the... No, sir. Can you send me the recordings from all of the classes?
Okay, I will send.
Done, sir.
Okay, you got it?
Yes, sir.
So, can you explain briefly? Tell how much you have read. What is the ending point
Sir?
here?
Yes.
Did you read this one? Magnetic storage, and optical storage, and solid state storage. Did you read?
What, sir?
Did you read magnetic storage, optical storage, and solid state storage?
Yes, sir.
So you understand
No, sir, that much.
which one? You don't understand?
Sir, the magnetic storage.
Basically, secondary storage comes in three forms. Okay. If we
Okay.
talk about secondary storage, it is given in the material here. This one, magnetic secondary storage, hard disk. So basically, if you talk about secondary storage, this is secondary storage. So you will find magnetic storage, optical, and then solid state drive, or you can say flash storage. Okay, flash storage. Okay.
Okay.
Now, first we talk about magnetic storage. So magnetic secondary storage, they are talking about basically hard disk. Hard disk, basically, I will show you hard disk in a second. They don't have shown. I show you magnetic storage. Now see this one. Can you see?
Yes, sir. Yes, sir.
This is hard disk. This is the internal structure of hard disk. Okay. Here you can see internal structure of hard disk. So basically, hard disk has a plate, a number of plater. We also call plater. See here. Here you can see.
Okay.
Okay, these are plater. Okay, these are round.
So, so what is the skill type on the disk?
Yeah, this is hard disk. This is called hard disk. This is the internal structure and magnetic storage. It is part of magnetic storage. Okay.
Okay, okay.
Here you can see magnetic storage. So hard disk have a number of plates. These are plates. Okay. These round things you can see. These are plates. This is read write head. This is called read write head. Used to data read from the disk or write data on disk. Okay. This is the spindle.
Okay.
This is the spindle on which plater are mounted. Okay. So basically,
Okay.
now here it says inside a hard disk drive is a stack of disk called plater. Okay, it is talking about called plater. So with a magnetic coating on each surface. So each plater is basically have a magnetic surface, tiny magnetic recording head on the end of an arm float a millionth of centimeter above the disk, spinning at 110 kilometer per hour underneath. So read write head moves. It is talking about read write head. Oh, sorry, spindle speed. There is a spindle. Okay, that moves, its speed is carrying at 11 kilometer per hour. Okay. So when spindle moves,
Okay.
plater also moves. Okay. So data is recorded on each disk along circular track, split into smaller part called sector. Okay. Now we talk about there's a plate. On plate you will find number of circles. Kind of that.
Circuit.
This is called track, and these tracks are divided into sector, and each sector basically hold data. Each sector hold data. So this is basically sector which occupy the data. Okay.
Okay.
The data is recorded in each disk along circular track. Each track, circle are called track. Each split into smaller part called sector. When data is read, so it says the arm moves across to be above the right track. Okay. So the required sector comes around the under the head. The surface behaving like a magnetic cause a tiny current in the head. The disk controller transmits this ones and zeros. Basically, there is a disk controller which produce zeros and ones. Zeros and ones. So because
Once.
each step data does not from the disk immediately, so each step takes some time. The time for step 1 is called seek time. For step 2, it is called latency. Now, when you whenever you have to read data from hard disk, okay, first it has to search track. Okay, finding. Yeah. Okay. Wait a second. I am writing it again. Okay. Time taken time taken to find particular track
Track.
is called seek time. Okay. Okay. Second is
Okay.
time taken to locate a particular sector is called latency. Okay. Whenever hard disk has to find a particular track is called seek time. So whenever when first it finds the track, then it finds sector, because track consists of many sectors. Okay. Now optical discs have three kinds of storage, CDs. One is CD, DVD, and video. If you talk about optical storage, so you will have first it came CDs, CD-ROM, then DVD, and then Blu-ray. So these three kind of storage devices came in the form of optical storage. It said this is made up of several layers as shown in the figure 4.13. Okay. We need to see 4.13 here. So it says data is written along a single track that moves out from the center of the disk in a spiral. This is optical disk store data in a form of spiral, like here. Data are read or written in a spiral form in a series of all optical disks. You got my point?
Yes.
Okay.
Yes, sir.
So it basically CD and DVD both uses red laser light. Both uses red laser light. Blu-ray devices use blue laser light. Got the point?
Yes.
Here we can see. Okay, now go through from here to here. Just go through. Then ask me if you find any confusion.
Done, sir. Sir?
Okay. So you understand?
Yes.
So basically, uh, optical discs store data using red laser light, and let's say the player uses two lasers, one to write data onto the disk and the other to read data. Okay, you got this point?
Okay.
So when writing one
Yes.
laser head, the recording material, this creates non-reflective bits on the surface of the disk. So where the surface becomes lower than the parts around it. So this is slow because the heading, heating and cooling of the surface takes time for each bit of data. If a CD is already written, when it is manufactured, it has bits in the recording layer. Okay, that are less reflective in the ref, less reflective than the flat part called lands. Okay, so data basically read or written on using bits and land. Okay. Okay, now see this one, flash drive. Yes, Taha. Go through this one from here
Okay, sir.
till here.
Okay. पता नहीं.
Yes, Taha, have you done?
No, sir. Slowly, this means the flash drive only can be returned on one finger before eventually falling. Done, sir.
Okay, you understand?
Yes, sir.
Okay.
That's all for today.
Wait a second. Now complete this one, na? This one left. This one. Okay, go through this one, okay?
Okay. No. Done, sir.
Okay, so have you understood? Any problem?
Yes, sir. No, sir.
So what else we have? Cloud storage. Okay, just finish this one. So you know that, okay? Cloud storage. Do you have any idea?
Yes, sir. The cloud storage. The cloud storage के बारे में जानना, sir.
Yes.
So cloud storage is the backup in your computer or any device that save your data when you restart it.
No, basically cloud storage means data stored on internet. Okay? Not on a
Okay.
device. So you have access of remote server, remote storage. It is called remote storage. Okay? Data is stored.
Okay.
Data is stored on remote computer. Okay?
Okay.
So wait a second. So data stored on basically remote computer. It says sometimes it can be useful to have your secondary storage in a different place from your computer. For example, you might want to have a backup copy of your data in a secure location or share your data with user of other computers. So, or you might want to be able to access your data when you are not sitting at your usual computer. So you want to access data from anywhere. So in Unit 5, you will learn more about how networks can be used to share computing resources. The computers that share their secondary storage across a network are called file server. Okay, and you are probably used to using the secondary storage on a server on your school network. Okay, your school have computer lab.
Yes, sir.
So there is there any server?
Yes.
So, sir, do you store data on server or your own?
Yes, sir.
Okay.
Yes.
So it says your home drive or a learner shared area. So some hard disk drive are able to connect directly to a network called NAS or network attached storage. Other connect to several servers using their own storage area network, SAN. NAS and SAN. These are two different things. NAS and SAN. Storage area network. This type of arrangement is useful when it's important not to lose access to your data. For example, in a banking system, if one server or hard disk fail, another can take over its job without user of the system even noticing. If one server fails, all data can be transferred to another server which is available as a backup. So you will not notice, but behind the scene, people are working on that to make sure your data must be available every time. Okay, you got it? So now
Sorry, sir. Actually, there's issue of my net.
the two Saha
What, sir?
you have connected through from two users.
No, sir. One.
One.
Yes.
Okay, now it says sometimes storage is accessed via the internet using internet service such as Dropbox or Google Drive. In this session, this is called cloud storage. Okay, this is an example of virtualization. So you learn, you seem to have access to a single virtual hard drive when in fact your storage might be spread across several servers around the world. So with software dealing with the details when each part of each file is actually stored. Here you can see how your data is stored. Okay, this is cloud storage. This is an internet. You might be here or you might be here. Okay, so using internet you can access this server and your data stored here. And the benefit is that you can access your data anywhere in the world. Okay, like cloud storage. Do you have Google Drive?
Okay, sir.
Do you have Google Drive?
Yes, sir.
So benefit of Google Drive, you can have data up to till 15 GB. You can store data free of cost. Okay.
Okay.
Now from here, take screenshot this one so you can memorize. From here we will start embedded system. Send me a screenshot. Send me screenshot.
Okay, sir.
Okay.
Okay, sir.
So see you inshallah on Sunday. Okay.
Okay. Allah Hafiz.